Hello everyone, welcome to this video. In this video, we shall be solving question 25 from exercise 9.3. So let's have a look at the question. In this question, they are saying if the four numbers are given to us, which are A, B, C and D. If they are in GP, then we need to show that this expression is true. We need to prove this expression. So if four terms are in GP, that means their common ratio would be same, correct? So B upon A would be equal to C upon B and it would be equal to D upon C, right? And all of them would be nothing but the common ratio. Let's call that common ratio as R. So from here, from taking these two, we have B is equal to A times R, correct? Now taking this and this thing, we have C is equal to BR and the value of B we have as AR. So substituting it here, we have the value of C as equal to AR square, correct? Now taking these two terms of this equality, we have the value of D as C multiplied with R. Now the value of C, if you see from here, is AR square. So substituting it here, the value of D becomes AR cube. Now we have the value of both all the three, B, C and D in terms of A and R. We can very easily solve our question, correct? So let's take the left hand side of the result. So let's take this particular portion. So we are taking this expression here and substituting the values. A square is as such, B is your AR, correct? So you have B square as A square R square, C is your AR square, so C square would be A square R raised to power 4. Then again B is AR, C is AR square and D is AR cube. Substituting all the values here, we have this thing. From here you see, from the first bracket you can take A square as common, right? Because it is appearing in all three terms. So we have A square common. We are left with 1 plus R square plus R raised to power 4. From the second bracket, you can take A square R square as common. So you would be left with 1 plus R square plus R raised to power 4, right? Next, you can see here this term is appearing twice in the multiplication. So you can write it as the square and you can combine this term with this term. So it would become A raised to power 4 R square and this. So this is your left hand side. Now let's solve our right hand side. The right hand side here is equal to AB plus BC plus CD whole raised to power 2, right? This is your right hand side. So let's take this thing here. Now here again substituting A would be as such, the value of B would be AR, the value of B would be AR, C would be AR square, C would be AR square and D would be AR cube according to the expressions that we have evaluated here. Because all the four numbers, they are in GP. Now solving the terms, what do we have? We have here as A square R, right? Next we have A square R raised to power 3. Next we have A square R raised to power 5. Now from here you see we have A square appearing everywhere, so we can take it outside. And moreover, we have R as common entity in all the three. So we can take it outside. So we are left with 1 here. We are left with R square here. And we are left with R raised to power 4 here. So squaring all the terms, we would have A raised to power 4, R raised to power 2 and this whole square. And if you compare, this is the same result as that you obtained in the left hand side. Hence, your left hand side and right hand side, they are both equal to each other. Hence, our result is proved in this particular case. And this is what we wanted to prove here. So I hope you understood this question well. Well, that is it for this video. Thank you for watching.